In this question, a type of brown coal undergoes combustion, and the question mentions that 19 megajoules is released for every 1 ton. Remember that brown coal and fossil fuels are mixtures containing various chemicals, hence its heat of combustion is generally expressed in kilojoules per gram. This is the same case, however, the units for the heat of combustion for this question is expressed in megajoules per ton rather than the conventional kilojoules per gram. But seeing the other units provided in this question, so they've also given us megajoules and they've also given us in tons, it doesn't appear that we need to convert this unit at all into kilojoules per gram. We also know that the power station is 39% efficient, so only 39% of the energy is actually useful. The question ultimately wants us to calculate the mass of coal required to produce usable energy that amounts to 42 megajoules. There are a couple of ways that you could answer this question, but you'll reach this exact same answer in both approaches. To begin, I'm going to first calculate what is the total amount of energy needed if this process is going to be 100% efficient. So what I want to do is I'm going to set up the following ratios. We know that 42 megajoules is produced when this process is 39% efficient. So I'm going to write 42 megajoules is released when it's 39% efficient. What would be therefore the amount of energy released if it was 100% efficient? So if you set up the following ratios, you could therefore write this over here as an equation where we can solve for Q, the amount of energy when it's 100% efficient. So if you cross multiply and solve for Q, you're going to get an answer of 107.69 megajoules. So this is, as you can see, a lot higher because this is now efficient. Once we figured out what is the total amount of energy when it's highly efficient, we could actually now calculate the mass. So in this case over here, delta H is measured in megajoules per ton. So I could therefore substitute this value over here as my delta H. The Q is this value over here, and now I could solve for M, the mass in tons. So if we're going to rearrange this, 107.69 divided by 19, you're going to get an answer of 5.67 tons.